Welcome to Lesson 2.2, Addition of Real Numbers for Algebra 1. So our rules of addition, we have two of them for adding real numbers. And in all my examples to start, we'll be using integers, not worried about decimals, but the same rules apply whether it is decimal, whole number, or fraction. So our first rule is dealing with two numbers that have the same sign, so both positive or both negative. The rule tells us to add their absolute values and attach the common sign. So we've always done something like 10 plus 20 equals 30. Both are positive, so we leave it as a positive. So our example here, showing that rule, if we have a -3 plus a -5, we add their absolute values. So 3 plus 5 is 8. And then we attach the negative sign at the end, giving us a -8. So you can think of it for the same sign rule as two positives always give us a larger positive. Two negatives will always give us a larger negative value. Now the kind of new rule would be the addition rule if our two numbers have different signs or different values. So the rule is if we have different signs for addition, so a negative plus a positive, you subtract the smaller absolute value from the larger absolute value and attach the sign of the number with the larger absolute value. So in other words, if we have something like a -2 plus a 9, we want to change it to subtract the smaller from the larger. So 9 minus 2 is a +7. Then when we look at our original, was the +9 or the -2 the greater absolute value? The positive had the greater absolute value, so our final answer would be a +7. If this was a +2 plus a -9, then our final answer would be a -7. So in this case, because we have more positives, our answer is a positive. Then our four properties of addition still apply even if we're dealing with integers or positives and negatives. So the first property of addition is the commutative property. Commutative property allows us to flip the order of addition. So a plus b equals b plus a. So in other words, -3 plus 5 is equal to a 5 plus a -3. The associative property of addition allows us to change the parenthesis groupings. So if we have in our first side, in parentheses, a plus b, and then outside the parentheses plus c, that's the same thing as a plus inside the parentheses b plus c. So our example here, 2 plus 4 in parentheses plus 5 is the same thing as 2 plus the quantity 4 plus 5 in parentheses. Then we have the identity property, which the identity property states 0 added to any value is itself. So a plus 0 is still a. So a -3 plus 0 equals a -3. And then our last property of addition is the inverse property, which states if we add opposites, they equal 0. So a plus a -a is 0, or 7 plus a -7 is 0. So example 1, parts A through F, are just finding each sum. So applying our first two rules at the top for addition. So if we have the same signs, we just add them and keep the sign. Opposite signs, we want to subtract the smaller value from the larger and attach whichever sign was with the bigger value to start. So in A, we have 5 plus a -8. So that's 8 minus 5, which is 3. And we had more negatives than positives, so our answer would be a negative 3. In B, we have a negative 5 plus 8. Doesn't matter if the negative 5's in parentheses or not. It means the same thing, negative 5 plus 8. So then 8 minus 5, and in this case, we had more positives to start. So our final answer would be a positive 3. In C, a negative 5 plus a negative 8. So they're the same signs. So 5 plus 8 is 13, and we simply attach the negative. Now in C, D, and E, along with F, we have 3 steps or more. So in this case, because it's all addition, you just work it left to right. So a negative 4 plus a 10 is a positive 6. And then 6 plus a negative 6 is a 0, because that'd be 6 minus 6. In D, 23 plus a negative 17 to start. 23 minus 17 is 6, and we have more positives, so it's a positive 6. And then plus a negative 8. 8 minus 6 is 2, and we had more negatives, so it's a negative 2. In E, it's decimals. We still just work it left to right. So 1.4 plus a negative 2.6, more negatives than positives, so I know it will be a negative. 2.6 minus 1.4 is 1.2. So we have a negative 1.2 plus 3.1. 3.1 minus 1.2 gives me 1.9. And in F, we have a negative half plus 3, which gives me 2.5 plus 3 halves. 2.5 is the same thing as 5 halves, because 2 times 2 is 4, plus 1 is 5. So we have 5 over 2 plus 3 over 2. That equals 8 halves, or 8 over 2, which is the same as 4. Example 2 gives us the directions to evaluate. So evaluate tells us we'll be dealing with a variable or substitution, and then we need to solve. So they gave us a value for x to substitute in. So in this case, x equals 3. So we have 4 plus x plus 10 plus a negative 12. I rewrote it, substituting the 3 for x. 4 plus 3 is 7. Then 7 plus the 10 is 17. 17 plus a negative 12. 17 minus 12 is a positive 5. And then in B, we're substituting the negative 12 for x. So we have 9 plus a negative 8 plus a negative 12 plus a negative 3. 9 plus a negative 8. 9 minus 8 is 1. 1 plus a negative 12. 12 minus 1 is 11, and we had more negatives, so it's a negative 11. Negative 11 plus a negative 3 would give us negative 14. And then our final example for today's notes is a word problem dealing with profit and loss. Anytime we hear the term profit, that represents a positive value. Anytime we hear loss, that represents a negative. So the company had a profit of $3,600 in April, $2,900 in May, a loss of $4,500 in June, and a loss of $2,200 in July. Did the company make a profit in the 4-month period? So what we're going to do is add the 4 months together. 3,600 plus 2,900 are 2 profits, plus a negative 4,500 plus a negative 2,200 are 2 losses. So work that left to right, and we get 6,500 plus negative 4,500 plus negative 2,200. 6,500 plus negative 4,500 is a positive 2,000. So then 2,000 plus a negative 2,200 gives me a negative 200. So in that case, the company did not have a profit. Over the 4 months, they had a loss of $200.